Hello, in this video we will look at how to debug a Renesas RA Family MCU secure and non-secure project pair. We will be using Renesas E2 Studio IDE along with an EK RA4 M3 evaluation board with its integrated J-Link OB debug probe. Note that the creation of the secure project and non-secure project were covered in separate videos. So here we are inside E2 Studio. You'll notice that in the Project Explorer view, we have the previously created secure project demo_s and non-secure project demo_ns. Thus we have access to both projects at the source level. So the normal way of debugging in this situation is to start the debug session with the non-secure project selected in the Project Explorer view. But to understand how this is going to work, we will first of all open up the debug launch configuration file, which controls all of the settings in our debug session. This is not something we normally need to do, but it is useful to help understand what is going to happen here. So I go to the green debug button on the toolbar and use the drop-down menu to open the available debug launch configurations in my workspace. The one that I am interested in is demo_ns debug SSD for the debug build configuration of my non-secure project. The tab I want to look at is the startup one, and in the load image and symbols table we can see both the image for this particular project and also the ELF image for the secure project. And both of these are going to be loaded into the debugger and down to the MCU's flash memory. So having seen this, we can now close the debug configurations dialog. The other thing I want to highlight is the way that the secure project requires the MCU's memory to be partitioned between the secure and non-secure worlds. This can be seen by opening the debug folder of the secure project and viewing the RPD device partition file. So for example, in this case, we can see that the secure portion of the flash for this image needs to be set to hex 1000 or 4K in size. So now, after confirming that demo_ns is still selected in the Project Explorer view, I will launch the debug session, which I do by clicking on the green debug button on the toolbar. The debug session starts up, displaying information as it does here in the console view. In particular, note that the trust zone boundary partitions have been set up to match the secure project's requirements for splitting memory between secure and non-secure worlds. This setting of the trust zone boundary partitions requires special support in the J-Link debug probe to allow communication with the MCU's boot mode. This requires additional pins to be available on the debug header beyond the standard SWD pins. Please see the RA4 and RA6 quick design guides available from the Renesas website for more details. Anyway, we can see that after launching my debug session, we have ended up at the reset vector with the code from the secure project. We can confirm this if we hover over the source file tab for the current program location counter indicated by the green bar, as this shows us the path along with the file name, and we can see at the start of the path demo_s. Another thing to note is at the status bar at the bottom of the E2 Studio window, we have the text SSD:secure. The SSD indicates that the MCU is in the secure software development device lifecycle state, but more importantly for this demo, the secure tells us that the MCU is in secure state, as we would expect. So if I click on the Resume button to start execution of the program, I next hit the temporary breakpoint set on main. Again, if we hover over the source file tab, we will see that this is the one from the secure project for the demo_s in the path. Now what I want to do is skip through the rest of the initialization code in the secure project and reach the main function in the non-secure project. The easiest way to do this is to set a breakpoint. So I switch to the Project Explorer view and drill down through demo_ns to the file main.c in the RA Gen folder. I open this up, check from the hover that I'm looking at the right file, and set a breakpoint on the line containing the call to HAL entry function. And again, if I hit resume, I now end up at the breakpoint on my non-secure code. And notice that on the way, the MCU has changed into non-secure state, which we can see from the message on the status bar. From this point, I can debug the rest of my non-secure code as per a normal debug session. And that brings us to the end of this demonstration of debugging our secure and non-secure projects.